What's going on, YouTube? Welcome back. In this week's devlog, we're going to take a look at the combat in my game and fix some graphics bugs. We finally reached the point where I can show my progress week by week, so you guys are up to date with where I am. And I've even upgraded my production values a little bit with some background music. So let's check it out. While making the first two videos, I noticed a graphical bug around the edge detection and transparency in my game. The bug would cause the edging or the solid lines that you see in the render to go on top of transparent objects. And you can see this in this screen on the ice cream fridge. In 3D rendering, it's common to separate drawing out all of the opaque objects from drawing all the transparent objects. And so normally you draw everything that isn't transparent at the beginning, and then you layer on top of that all of your transparent objects in a separate step. And that's done so that it can blend the background colors through. My issue here was I was passing along all of the information for my opaque objects to my edge detection, but I was having an issue with my transparent objects, leading to this bug. I thought it might be kind of cool to talk a little bit about the edge detection algorithm. In my rendering pipeline, I add the edges to the scene after the fact, and I do that using this edge detection step. To do this, I started out using what's called a Sobel operator, but I ended up switching to a pre-wit because I liked the results a little bit better. Without getting too technical though, the edge detection works by looking at one pixel and comparing it to the pixels around it to see if there's a big difference. If there is a big jump, we assume this is an edge, and in my case, I draw a line there on the outputted image. Now you can use this algorithm on regular images, but with my game, to get better results, I apply it to information on how far away every pixel is from the camera, as well as some information about the surface in each pixel, or the normal vector as it's called. And I've rigged up some beautiful drawings here to illustrate this. So imagine this yellow line is a surface, and every time I draw a red line here, I'm looking at one pixel to see how far away that surface is. So between these two lines, it's not much of a change, so we won't say that's an edge. Next one's about the same. Until eventually, now we're gonna have a big jump between these. And this illustrates how you can use the depth or how far away each pixel is to determine if there's an edge. And if you're interested, this is what an image would look like that has depth values. So I've adjusted this a little bit, but these are colors between 0 and 1 to represent how far away each pixel is. And this is before we do transparent objects. So using just a texture with depths, you can get pretty good results, but there is one use case you have to look out for. So with this image, you can imagine with our two checks, which you'll see here, the depth hasn't changed very much, but clearly we can see there's a corner between them. And so this is where that surface information comes in, or that normal vector. So if we look at that, we can see there's been a big change. And if you want to see what one of those images would look like, I have this screenshot. The actual details of this, I wouldn't look too much into because I do have some encoding going on that's a little bit confusing. So getting back to the bug, my problem I was having was I was storing the depth information when I draw transparent images. So this is the opaque, and now here we see the transparent. But I wasn't sending all the information for the surface. So you can see here, this is what the surface looked like for the opaque objects, but I wasn't sending the transparent objects. And that resulted in this edge detection. Now, of course, the solution to this was pretty straightforward. I just had to make sure that I saved and passed along the surface information for the opaque objects, which you can see here. And what's pretty neat is now I'm actually blending the normals. So that's why you can see the edge detection through the pane of glass. And this is now the updated rendering pipeline. I thought all this made for kind of a cool before and after and discussion on edge detection. Of course, if you want some better resources, maybe with some better drawings, there's plenty online you can check out. After spending a lot of time looking at edge detection and really obsessing over it, I realized I had another bug here, this time around the particles in the edge detection. And you can see in this video, my problem that I noticed was I'm actually drawing my edges on top of my particles. So here you can see the edges on the main player on top of the smoke particles. And similar to what I was talking about earlier, this ended up being a pretty easy solution. This was just a matter of I was applying my particles and then applying my edge detection, so I just had to switch the order. Of course, with OpenGL, it has a lovely way of making that very straightforward solution take quite some time, but here's the updated solution now. You can see the edge detections being covered up by the particles. So after spending all of this time on visual fixes, I was now ready to actually get to work on some of the combat, which was my goal this week. From a functional standpoint, the programmer in me, I think, would say most of the gameplay, the combat works, aside from a bug or two, mostly around pathfinding. But what it's really lacking is just the fun and trying to make it more engaging. There's 5 enemies in the game, and this is the first one. They just chase after the player and try to attack them with a melee. I found initially when I was working on the white box prototype that a lot of the fun in the game came from trying to avoid enemies and trying to plan ahead of where you're going to go while also trying to shoot at other enemies. And so using that as kind of a guiding principle, I wanted to make some changes to improve things. Right off the bat, pretty easy changes were I felt like I should increase the animation speed on both the player and the enemy so that it looked like they were covering the right amount of ground as they moved. I also wanted to increase the enemy speed so it was the same speed as the player so that you would have to really focus on rolling and moving ahead of them. I had updated my UI at this point as well, as you can see in the bottom left corner, and I didn't have a health bar anymore, so that was another item I wanted to accomplish. Early on making the game, I added a reload mechanic to this gun, mostly just because I felt like I should add it in. I was programming my engine, but I think that staying in line with that idea of trying to stay away from the enemies while shooting them, I felt like I should just remove the reload so it's a bit more pure of focusing on movement and gameplay. The enemy pathfinding also needed some massaging, both in terms of kind of setting up the system I already have and also making some changes so that you don't end up with as many bugs with the enemies kind of locked together. And the final thing I felt like I should add in was some improvements in terms of the feel. So I felt like particles was a big aspect of this. When you shoot the enemy and when you kill the enemies, I wanted better particles, but also a little bit of impact when you hit them. I thought it might be fun to show my pathfinding system. So this is my editor in the engine that you can pull up. You can do this and then you can take a look at the nodes in the pathfinding system. I've implemented a full A-star pathfinding system in the game, and you can place nodes and move them around to control how enemies will move throughout the level. So this is the nodes that I have in this level currently, and you can select a node and take a look at its neighbors as well as the paths that an enemy will take moving between them. I've actually implemented Bezier Curves, but I don't really use them for much. I just thought it was a cool idea and I thought it might help. As I drag this around, you'll see the blue line, or the blue line curves around. So I can set that up with those control points, but I've usually just made the enemies walk straight. This week, in terms of the pathfinding, I just adjusted some nodes, but I'm going to talk a little bit more later on. I do have some big AI changes to make. One of the big problems I've encountered is every enemy usually takes the exact same route after the player, so I want to add in some randomness so they try and surround the player. I spent a fair amount of time this week working on particles in my engine. One of the joys of making your own engine is oftentimes you end up implementing features when you should be making content. So as I started working on particles and hit reactions, I realized that I need more blending options with my particles. And you can see this on screen here. By default, I was using what's called additive blending. It works really well when you have a lot of particles with transparency and you're layering on top of them. But it doesn't work great for blood, as you can see, as these really just kind of look like flames more than anything. This is once again my in-engine editor I can use to configure and change around this particle emitter. So here I've adjusted the lifespan and now they're kind of blooming out. The extra blending option I added in was standard blending, which you're going to see in a second here. This has the depth testing disabled, so I'll switch it in a second. And yeah, now it doesn't overwrite. Obviously pretty chunky particles, but I do like that for blood it looks a lot more solid. I have some work still to do with the textures to make them look a little better, but I was pretty pleased with this. And so with this new blending option, I made 3 particle effects. One for when you hit the enemy, and 2 for when they die, which I combined together. This is the death ones playing now. With my snazzy new particle effects, I thought it would also be kind of cool if I could have some hit reactions on my enemies. And so I thought maybe I could do something with my skeletal animation system so that they would react programmatically via the bones. This is my demon monster I made, open in Blender here. There's my materials. Early on in developing the game, I actually implemented a system similar to what I want here. It was actually for the player controller. Because it's a dual joystick shooter, I wanted the player to be able to rotate their upper body and keep their legs moving in the direction that they're moving. So I had a system so I can rotate a given bone by a set amount. Now prior to this, I had that hard-coded to along the y-axis. So as you can see here, the torso can rotate. Looks a little bit rough with my Blender setup, but the idea I had was maybe I could use that system, and instead of hard coding it to the y-axis, if I rotated on the x-axis, their head would kind of get snapped back. I guess their torso would get snapped back, and hopefully have a decent reaction to getting hit by a bullet. All I had to do once I had that system set up was just detect when they were hit by a bullet and then begin to rotate them backwards, trying to make it pretty quick so it looks like a fast impact. And the really great thing with this approach is because I have these animations moving fluidly, by applying this rotation in code, it's still animating through all of its animations and all of its keyframes, and it's doing it on top. And so I don't have to go through and try and handle every single animation where they get hit. Here I'm switching, I was on the backwards walk, switch my camera view. So here's like a melee where the same thing can happen. Combining everything I've talked about together, this is the update. So you can see I have a health bar there, that half circle. I'm not necessarily married to it, but it does fit the UI a little bit better. You can see the updated particles. When I shoot the enemy, they kind of snap back a little bit, which I'm into. And we'll see if we can get a death particle effect here too. There. And I'll actually do a little demo here. I'll show that rotating the torso, how that actually works. I can bring my camera in here. You can see my main guy walking around and twisting the torso, and then we're running around, the legs facing in the direction of movement. Adding in all these changes, I was pretty happy with the results. I do feel like it's become a fair amount more fun and engaging, especially with the movement speed changes, but I started to realize I need some more AI changes. So one of the big things was initially I had some code in place to try and detect when 2 enemies are running together and they kind of stop. But I found that having more enemies on screen, sometimes they would get locked together and block a corridor when 2 enemies are trying to go 2 different directions. And so I decided to turn off enemy-enemy collisions. You can see here they all kind of swarm. I think this is better for gameplay, but I do have to introduce some randomness to match this. So already with this, I've added in some variability in the animation playback speed and the movement speed, so they all move a little bit differently. But to match this as well, I think I'm gonna set it up so instead of all going directly to the same nodes, I'll generate a random offset. I also thought about adding some randomness in the animations to see if that would help. And then I mentioned it earlier, but I also want to have some randomness for path selection. That's kind of a tricky one because I want them to take different routes, but I also don't want them to take suboptimal routes. Like I don't want them to take the long way around. Alrighty, that's going to do it for devlog number 2. So this week we fixed some graphic bugs. We improved the combat, still have a ways to go, so we're probably going to be looking at that next week, but some good progress. I'm going to talk to you guys next week, and until then, see you later.